Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today we'll be talking to Dr. Bill Raun about the Oklahoma State University hand planter. What are some of the obstacles Central American maize farmers face when planting using traditional methods? What kind of tool would help overcome these obstacles? How would we know if it works? Answers to all these and more coming right up. I'm your host, Abby Morrison. Let's talk about science. Hi, Bill. Welcome to the show. How are you doing today?
I'm doing absolutely awesome.
Wonderful. I am super excited to do this show today. We met like a year and a half ago, somewhere around there, and I remember you talking to me about this project, and this has been one that I've wanted to record since basically the conception of the idea of the podcast. So I'm super excited to have you on the show today. But why don't we start out and you can tell me a little bit about yourself, just kind of how you came to your field of science.
Okay. I talked to you in Madison?
Mm-hmm. The editors conference.
All right, which I'm no longer a part because my tour of duty came to an end, and my new editor is Jerry Hatfield for Age and Agrosystems, Geosciences, and Environment. So that has been fun. And Jerry Hatfield is a wonderful guy.
Yeah.
So about myself, I grew up in Mexico and Colombia. The school year was basically spent in these Latin American countries. I did spend the summers on a farm in Nebraska from the time I was 3, 4, 5 years old. And once I decided to come back to the United States to get a degree, then I started at Oklahoma State University. Then a couple degrees here at OSU, and then a PhD at the University of Nebraska. After I finished at Nebraska, then I spent 6 years in Central America. Most of that was in Guatemala City. And 2 of those years were with CIMMYT in northwestern Mexico. And then the last 27 years, I've been a professor here at OSU.
Wow, that's awesome. Kind of all came back to OSU. So before we get started, we're talking about your hand planter project, but there's a website that you manage for that, and you had mentioned to me that that would be helpful if people wanted to follow along. So if you want to tell people how they can get to that website, that would be awesome.
Yes, absolutely. The website's very easy to find. Just go to Google, type in OSU, as in Oklahoma State University, but just type OSU hand planter, and that site will come up first.
Awesome. So, as I said, we're talking about a hand planter, but can you give me some of the background of the problem that sparked this project, how seeds are traditionally sown in these countries, and some of the problems that can cause for the farmers?
Sure. So, if you're following along on the web and you very quickly found that website, there's several pictures on the left-hand side that I kind of want to go to, but I can describe them if you're sitting in a car or listening to it on the radio. In Central America, no different than South America, a little bit different in Africa, all of the maize that's planted, the same 80 million acres of corn that we plant in the United States has another 80 million acres of corn, or 30 million hectares, that are planted by hand, where it's planted by hand, weeded by hand, harvested by hand. Everything is done by hand. But what's critical there, and if you're, again, on that website, you can go to those lower left pictures, is that there are terrains and slopes that are really troublesome. Terrains and slopes that will never be mechanized. And so that is the issue in terms of why they have to be managed by hand. But the picture that kind of bothered me, and that's included in one of the CSA articles that ASA put together was a picture I took of a man planting corn in early spring on a hillside where I almost fell over. And again, that was in 1987. And as I looked down that hill to capture that image, he's planting this corn, and it's very good corn seed. They're planting hybrids on these slopes, and that picture is in El Salvador. It's just north of the capital, which is San Salvador. He's using that seed, but the seed's chemically treated. Those chemicals that we use on maize seed were not intended to be handled by hand. And so when he goes from step to step, as you can kind of imagine that if you clicked on that picture, is that he moves forward, he's reaching into a bucket where he's carrying the seed on the side attached by a little belt, that he's throwing down 2 to 3 seeds for every strike, and then he moves on probably 12 to 20 inches apart, and will throw down another 3 seeds. But each time, then he's got skin to seed contact with those chemicals. And again, the chemicals do their job, but chemically treated seed was not intended to be handled by hand. Another one that I wanted to quickly mention is the women in agriculture. So it wasn't just the men, that he was out there. The women, and especially in Africa, but in Central America a little bit less, they're touching the seed. And so if they're carrying a child, the contamination that arises there then can lead to birth defects. It gets horrific. It gets horrific rather quickly.
Right. And just for anyone who can't see the pictures, basically the process is they have a stick that they just jam it into the ground and then take a couple seeds and throw it in, and then they kind of slide their foot over to cover the hole, and then they just do that for their entire field, right?
That's correct. And the average farm size is about 1 hectare, so it's about 2.2 acres. And that's consistent no matter whether you're in Africa, Central America, or South America. And he's doing that all by hand. So, yeah, it becomes important in then that labor force. But at the end of the planting season, when I worked in Central America, one of the things that would come up is that these guys would tell me they'd get sicker and sicker. And the reason they get sicker and sicker is because of the buildup of the chemicals that would be imbibed through the skin that's on our hands. Now, very quickly you would say, well, why don't they use rubber gloves? Or why weren't you working in that arena to push them along the line? And the answer is, sure, we did, but they do not want to wear those gloves. They would rather knowingly get sick and use their hands because the seed that they're planting is good seed, and they clearly had to pay for that seed, but don't like the gloves because of the humidity and the stickiness that then the dexterity in being able to throw down 2 to 3 seeds diminishes rapidly.
So how did you get the idea or really get the project started? How did your involvement in those countries lead to you creating this invention here?
Well, I worked as an agronomist in Central America. I actually worked as a maize agronomist or a corn agronomist. So that was my job. Being in that field, I was in that kind of field throughout Central America. My region was actually Panama, Costa Rica, Nicaragua, El Salvador, Honduras, Guatemala, and then all the Caribbean, Cuba, Haiti, and the Dominican Republic. So I was on the road a lot. Did I have the idea to put in play a hand planter in 1987 when I first took that picture of that man planting? I did not. I knew there was a problem, but I did not work with the right people. And I'm not an engineer, I'm an agronomist. So when I took the faculty position here at OSU after spending 6 years in Central America, I knew immediately that I had to work, if I could, with a mechanical engineer to get something going here in the U.S. And when I was finally promoted professor, I felt like I had some latitude to to do some things that might not be perceived as, benefiting the state, benefiting the people that were paying my salary. And I was cautious about that. But I just knew that if I could work with a couple of engineers, or one anyway, that I could get going. So John Soley and Marv Stone were the two mechanical engineers and electrical engineers, respectfully. I asked them, I said, I know you've got a ton of stuff to do, but I said, this is a hand planner that I owe it to Central America. I felt like I needed to give back. And so John, at the start, really only let me use his student engineers, but I was happy to work with whomever would listen to me. And it was a fun start, but it took us a long time to where then a couple of the engineering professors here got involved. They could see what some of these undergraduates were doing and the value, and then they gave it some more serious attention. The most recent was Randy Taylor, who's a mechanical engineer as well.
Yeah, that's one of the things I love about this project is just these collaborative relationships you've had, having all of these different people. I mean, obviously the students move on and go to other places, but to just have so many people over the years all working towards this common goal is really awesome and inspiring. So that's one of the things I love about this project. But moving on, could you talk about some of the specific objectives, design-wise, that you were shooting for with this?
Sure. One thing very quickly, kind of in response to your comment, is that I would say from the very start that this project has also been fun, kind of an odd word to use in kind of a research arena, but it's been fun because both the students and the professors that kind of agreed to work with me understood its value. And publishing, for example, we've published a bunch of papers on this. It's not about who's the first author or we don't care. It's just to get the publications out there. And again, that is reticent of and reflective of the fun that we have had. Research doesn't have to be laborious and boring. It can be an awful lot of fun. It's so long as embedded in that process that you're doing the right thing, and that it's heartfelt. That I don't know, it makes it go a lot faster.
Yeah. So
design criteria. Big thing is that it had to singulate seed. I mean, the issue is that producer in Central America is throwing down really good seed, hybrid seed, but again, it's treated. And so throwing down 2 to 3 seeds and then moving on a foot away is incredibly inefficient. What happens is for those 2 to 3 seeds that he throws down per strike, probably all 3 will come up because the germination percentage on the seed is quite good, but 2 or 3 will abort, but not before competing for moisture and nutrients. So it's an incredibly inefficient process. If I can throw down 1 seed for every strike and then having them be closer together. So it's not just that we get singulation, the planter delivering 1 seed for every strike, is that I also get homogeneity of plant stance. So if you can imagine you're on that hillside with that farmer and you're looking down that hillside, if I've got plants evenly spaced 7, 8 inches apart instead of 2 or 3, 12 inches apart, I can decrease soil erosion as well. So there's a big benefit there. And then if I have improved homogeneity of plant stands, even stands evenly distant and apart from each other, I can almost double the yields, double. So that heterogeneous plant stand is a huge strike against that producer. He doesn't know it, she doesn't know it, but we know it from a lot of our work. There's a gentleman by the name of Emerson Nafziger. He's at the University of Illinois. I'll bet that Emerson does not know how much we use some of his work and the importance of that work of the homogeneity of plant stands, but really helped us in this process. So homogeneity and singulation.
Could you also describe the actual mechanics of how the hand planter functions?
So for those that are following maybe on the website, there's two large icons that say 1 minute video. And if they could click on that 1 minute video, and it does take exactly 1 minute, it basically shows in motion exactly what's taking place. It goes through a justification as to why the hand planter works and why it's needed. But for those of you that are just listening, you strike the ground, and for every strike, it throws down one seed, because we actually have an internal drum that's inside that hand planter that for every strike, then it can either relax or not relax. And as it lifts itself out of the ground, it'll drop the seed straight into that hole. It's kind of magical of how it was that we got there, but it does work incredibly well.
Can you describe your experimental design for how you plan to test different versions of the hand planter?
So this has been a totally different project that an agronomist, we're running out there and running randomized complete block designs and 3 replications and things that are in the field. But this project was nothing like that. It was just the different issues that we were evaluating as a function of time. You had asked me earlier about seed bridging. We found that if it was moist enough, that seed would form kind of a bridge above the reservoir where we were wanting to drop seed, and it would basically prevent the planter completely. And so we had to develop different methods to disperse the bridge, whether it was external agitation, whether it was internal agitation, lots of different things. There were many different components that we ran into with the hand planter that did not conform with an experimental design the way we might think about it. Whether or not it was an internal brush on the inside of the planter that kind of would sweep off the drum, or scarifying that drum to create some friction so that you would not have the bridge. Early on, drum position and getting that drum to be in the exact same place each time for each strike to catch that one seed that would drop, and then to plant that one seed. It was more design and fail and fail again. We did that well, but finally, really got to a point where we had removed a lot of these variables. But the publication was fun, and to the reviewers' credit, they recognized that there were 25 different things that we were testing over the lifespan of about 20 years that are embedded in that publication. So they understood we weren't talking about an experimental design, but we had to communicate as much, because that's kind of what we think about in agricultural research. We kind of have a mindset.
One variable that I thought was super interesting was the operator strike style. Can you tell me a little bit about how that affected your design?
Absolutely. We found huge differences in the different operators in terms of singulation. We had one of our Ugandan students, Peter Omara, and another Ugandan student, Lawrence Aula, that were always a little bit higher than everybody else in terms of delivering close to 80% singulation, and then maybe 20% doubles. And the reason that they were higher is because they actually could kind of like feel that ebb and flow of the hand planter, that it couldn't be so mechanistic and rapid. They could actually kind of feel that seed drop in that cavity, and there was a more genteel, more flowing method of planting, almost consistent with what you would see if you were out there in the field today in El Salvador or Guatemala, take your pick, because they work exactly the same way. Now, are they familiar with this hand planter? They're not. But Lawrence and Peter kind of taught us that there was an ebb and flow that was better, and that also, as we're thinking about wear and tear on that person's body, that they could endure that for the entire planting season.
That's super interesting. I didn't realize that, but it's this cool kind of knitting together of the mechanical side and the human side, which, I mean, I obviously understood it's humans using a tool, but just how that impacts design is really cool.
That's exactly right. And yes, they were basically putting their mind and body into that planter so that we could deliver a higher level of singulation.
Oh, I love that. That's so great. I had no idea. I just love this project even more now.
Well, I told you it'd been fun, and I meant that.
Yeah, for sure. It's fun just to talk about it.
I mean, it's been challenging, don't get me wrong. We're going through a challenge right now where we're going backwards in terms of manufacturing. We've used high-end components now for the last 6-7 years, and we're going in reverse now where we're wanting to find more rustic components that might be more easily available in the developing world that we can use. So we have a model that works, but now we want to make it cheaper. That's our big challenge. I get input from all over the world pretty much all the time, random things that pop up. A guy from Bolivia, Colombia, please send me a hand planter. And I'm like, I would like to, but our big cost, and I don't know if that's your next question, but the hand planter that we have that's a little bit high tech, we're spending $120 a pop to get that produced. Well, that's cost prohibitive. It's going absolutely nowhere at $120 in Uganda. And so that's why we're kind of reverting back to this more rustic version that we think can be manufactured in country to get that planter back to a price that's in the neighborhood of $20 to $25. In Nigeria, they're now making the hand planter out of locally produced products. It's not quite meeting with the engineering tolerances that we need, but they're making a stab at it. They're wanting to manufacture it in country. That for us is the end game. If we can get them to produce them in country, sell them in country, that is then obviously going to take off.
I think it's really admirable just to see your perseverance throughout this project. I mean, you and your entire team, obviously, to really make this happen.
It's been, Abby, it's been a gift. If I look at it, it's been a gift to be able to work on this project. I cannot tell you. It's like it was a gift to stand on that slope in 1987 in El Salvador. And it was a gift to be able to, be promoted to a professor here at OSU. And at 62 years old, of all the things I've done in my entire career, this is by far the most important. There's nothing close. I've done some stuff, I don't know, it's kind of important, but not this important.
Yeah, that's super awesome. I love your passion for this project. Makes my heart full. Hey everyone, I hope you're enjoying today's episode. Interested in learning more? Bill's article, Hand Planter for the Developing World, Factor Testing and Refinement, is always freely available on our digital library. You can find a link to it in our show notes. Let's get back to the show. One thing I just wanted to clarify, when you were testing these, obviously you can't just go out in a field and then have to dig back in to count the seeds. So you actually had kind of an interesting solution to this, which was planting into mats. Can you describe kind of the work environment and who you had testing and all that kind of stuff?
Yes, we had a staging area that had to be reflective of the kinds of impacts that we would find in the field with soil. But we had to do a lot of this indoors. So over the winter, when we're testing a lot of these different components, we put down a lot of different rubber mats to the point that, again, it felt like we were getting the resistance that we would find in the soil on the outside, but where we could pick up and see and count the individual seeds as we were striking. No matter what the component was that we were testing, for tens upon tens upon thousands of strikes in those rubber mats. We have had a set protocol. No matter what the variable is, we run 100 strikes for each person, each variable that's changing, whether it's a drum or spring size or take your pick, but we get an N value of 100. And then if there's singles dropped for that, if I have a singulation of 79, means that I had 79 single seeds that dropped. Sometimes we have doubles drop, and so we have to record that, or triples. But the kicker was that we didn't ever want it to drop 0. That's the kiss of death. So we've been really cognizant, and those are termed blanks. We'll deal with doubles and triples. Obviously, we want singulation. That's the goal. But it's a hand planter. This is not mechanized planting. This is not a John Deere planter that's maybe a plate planter or a vacuum planter where you can almost guarantee 100% singulation.
Yeah, and that leads pretty well into my next question, which is about the results of your project. So obviously you have a final design, so congratulations on that. But can you tell me a little bit about how you did some of the field testing to confirm that, and just if you have anything you want to share specifically about how you met your design goals or not, or room for growth, anything like that, feel free.
Yeah, that is fun, where you're actually testing the new planter versus the common method that we know, and we're duplicating the farmer practice. Then we implement our practice using our hand planter, and then we've also in the field gone in and compared it with we have a small 2-row John Deere planter that we want to compare it to mechanized agriculture. So we compare those in a randomized complete block experimental design like any other treatment.
After you tested these, what did you find were the results?
Again, the big one is homogeneity of plant stands. If I can put down that seed 7 inches apart versus 12 inches, 2 to 3 seeds, 12 inches, 2 to 3 seeds, 12 inches, 2 to 3 seeds, I can double those yields. I can literally get double the yield that producer is getting on those slopes than where he's planting, provided that he listens to us and he goes with strikes of 7 inches apart and has to trust us of not going a foot apart like he's doing right now. That has been a little bit of a difficulty where he or she wants to do exactly what they were doing before. But therein lies the value of this planter, is that from day one, we wanted to emulate that planting method that he was using on those hillsides today.
Sure. Well, that's a pretty good transition into some of the future goals of this project. I know distribution of not only the hand planters themselves, but also how to use them appropriately. But do you have other future research areas for this project as well?
I think gender issues are important. The weight of the hand planter has always been an issue, where it's a little bit heavier than what he does, because instead of him carrying the seed on his side, like in that picture, that PVC that you see on the front page of the OSU hand planter site is the reservoir that we keep the seed in. So it makes it a little bit heavier. We're well aware of the weight. We would like to keep the weight as low as absolutely possible, because we understand and recognize that a lot of the women are doing the work, and a lighter hand planter comes into play. The other one that is kind of fun to think about is that, a lot of farmers that may be listening are well aware of these dole meters that we used on tractors to make sure that we were getting seed that was dropping. We would like, on this hand planter of the future, I want a red light that goes off every time, and that he or she can see it, a red light to go off every time that seed drops, because they will not tolerate blanks. That again is more of a futuristic hand planter, but I think it's doable. And this one, I think, will happen as well.
Sure. All right. I've got 3 questions left for you. The first one is, if people want to learn more about this project or this issue in general, where can they go?
Again, they can type in Google OSU hand planter, and it's not a great website because I'm the one that takes care of it. But it's kind of like a notebook. They can go to OSU hand planter and they can see everything that we're up to. There's a little brochure on what we're doing, how the planter works. There's that 1-minute video that they can see, and then they can kind of see where in the world that we're working. And that's basically everywhere that people will work with us. We've been working with Rotary groups of late because one of my cousins picked up on this project, and he says, you know what? He says, I think that we could deliver these hand planters through our Rotary chapters that, believe it or not, are all over the world. And it was actually the perfect vessel for us to get this hand planter out there, giving you the Paul Harvey start of the story. And I think the rest of the story, if Paul Harvey were here, is going to be that Rotary is going to allow us the tentacles to get everywhere.
Yeah. Second question then is, if people want to get involved or help out with this, what can they do to do that?
This is kind of oddish, where we do have an entity, it's called Indig Dev, where they can buy planters right now. That we've had several church groups that want to buy planters, and then they want to have, as a part of their mission, to deliver those hand planters. We love that NGO model because it makes sense, and everybody wants to feel good about what it is that they're doing. And we want to cater to those needs that are out there. Our big restriction right now is planters. I mean, I don't have planters. I have orders. It's not like I'm taking orders, but I got orders for 1,000. What I have to do personally is I got to get them out there in the third world, and I have to get them out there as cheap as absolutely possible because, again, I grew up abroad. I grew up in Colombia. I owe it. I owe this back. I've been given everything in the world. I'm fluent in Spanish. I can speak a little French. I've been given a lot of skills, and I got to give back. And I got to give back now. And I've got to get this thing over the cusp and in the hands of that producer. So I feel a real debt. Is kind of it's the right way to say it. I feel a debt that I owe.
Sure. So then the final question I have for you today is, what is one fun fact about you personally that people would not know if all they saw was your research?
I don't know. There's nothing fun. Absolutely nothing. I don't know. I dream in Spanish. I don't know. Maybe that's important. I think in, what happens is that when you grow up with 2 languages, is that you can very quickly move from one to the other because you think in that language when you're speaking in that language. You're not translating. It's basically just, it's there. And that has been such a gift. So, this morning I sent a couple emails in Spanish. I type them in Spanish. I don't really think about it because your mind goes into that language and very little translating back and forth. There is some always, because we are, as educated people, that gift of education gave us synonyms and antonyms and all these fantastic words that make communication so much easier if you're using your entire dictionary. But having 2 dictionaries, one in Spanish, one in English, has been a gift for me that just keeps on giving. And I have 4 kids, and most of them also are pretty good at Spanish.
That's awesome. Yeah, I speak like a little bit of French and a little bit of Japanese.
Oh, wow.
And very, very small amount of Japanese.
Kudos to you, Japanese.
But
wow.
I am not fluent in either.
Yeah, well done.
Thanks. I'm working on it. But yeah, it has been such a pleasure to talk to you today. So thank you so much for being on the show and giving us your time and giving so much of your life to a really important project. So thanks.
Abby, it's been an absolute pleasure. And again, the gift is mine, but thank you again.
Thank you for listening to Field Lab Earth. You'll find a link to today's paper and other resources for this episode in our show notes or on our website. If you have any questions, comments, or recommendations for show topics, please contact us at podcast@sciencesocieties.org or on Twitter @FieldLabEarth. If you'd like to hear more content like this, please subscribe, and don't forget to rate and review us on iTunes or anywhere else you find your podcast if you like our show. This podcast is a joint production of the Tri-Societies, the American Society of Agronomy, Crop Science Society of America, and Soil Science Society of America. Special thanks to Lobo Loco for the use of their song Spook Castle on the intro and outro of our show. Opinions and conclusions expressed by authors are their own and are not considered as those of the American Society of Agronomy, Crop Science Society of America, Soil Science Society of America, its staff, its members, or its advertisers.